Math 1332, Chapter 11, Statistics, Section 2, Picturing Data, Video 4, Drawing a Frequency Polygon for Numerical Data. This is the last video in the section and hence the last picture that we'll be drawing for data. A frequency polygon for numerical data is actually a continuation, or in my opinion, is a continuation of the histogram for numerical data. You'll see what I mean in just a moment. A frequency polygon is formed by connecting the midpoints of the tops of the bars of a histogram. In other words, if you already have a histogram, we're going to play connect the dots. The hardest part is accurately locating these dots, and we'll need 2 extra dots to both begin and end the polygon. Each point on the top of the bar can be thought of as an ordered pair of the form midpoint comma frequency. An ordered pair is as if you're graphing in algebra, you know, like 3 comma 2 means go over 3 and up 2. Now, what do I mean by midpoint? The midpoint of a class, remember each bar represents a class of values like 90 to 98. The midpoint of a class can be found by averaging its lower and upper limits. In other words, the midpoint of a class is the sum of the upper and lower limit divided by 2. A polygon begins and ends on the vertical axis. So if we just connect to the tops of each bar, it wouldn't start on the ground. It would start in the sky and end in the sky. Thus, it is necessary to determine the midpoints of the classes that would exist before the first class and after the last class. But the midpoints will form a nice arithmetic sequence, meaning that there's a same difference between consecutive midpoints. So you can use the common difference to determine these 2 extra midpoints. Let me kind of just give you the visual. This is the histogram that was drawn from the previous video. So if you haven't watched video 3, I would recommend watching it to see where this comes from. But the concept of a frequency polygon is actually really easy. All you do is you locate the points in the middle of the top of each rectangle. Each bar, if you will, and literally connect them. There's one. There's one. There's a reason I skipped that one. So the thing I just drew is the frequency polygon, almost. A frequency polygon has to begin and end on the ground, which means we have to find the midpoint of the class that would have existed previously and the midpoint of the class that would have followed in order to complete our polygon. Our polygon is literally the histogram's midpoints connected. And there's our polygon. There's nothing wrong with leaving the polygon superimposed on top of a histogram, but technically a polygon exists on its own. About the only other thing that we need to discuss is how to locate the points that we actually connect to form this polygon. To find the midpoints of each class, and I'm going to put the, let's see which way to do this. Nope. I'm going to put the bars back in there. I can always take them out later. But to find the midpoint of each class, all we have to do is average that class's upper and lower limits. For example, starting in the first class is 90 to 98. And so to find its midpoint, we simply have to do 90 plus 98 divided by 2. It's just the average of the 2 numbers. 90 plus 98 is 188. And if we divide that by 2, we get 94. Our first midpoint is 94. Let's go ahead and calculate all of the midpoints, and then we will see what to do with them. I can keep some of these things. There we go. For the second midpoint, for 99 through 107, we add 99 plus 107. That is 206. 206 divided by 2 is 103. Okay. For the next class, 108 through 116. 108 plus 116 is 224. 224 divided by 2 is 112. That is our third midpoint. For our fourth class, 117 through 125. Their sum is 242. 242 divided by 2 is 121. And for the last midpoint, 126 to 134, or rather I should say for the midpoint for the last class, 126 plus 134 is 260. 260 divided by 2 is 130. That is our final midpoint. And at this point, we can label all of the midpoints on our graph. And I'm going to type these in black so that they're a little bit easier to see. We'll bump up the font size just a little bit. For the first class, its midpoint is 94 and its frequency is 4. That is the ordered pair associated with that first midpoint. For the next midpoint, for the next point on the polygon, I should say, the midpoint is 103 and the frequency is 19. For the one at the top, the midpoint is 112. The frequency is 38. For the one right here, the midpoint is 121 and the frequency is 25. Just like we were plotting points in an algebra class, not really that difficult. And for the one at the bottom, or I should say for the last class, the midpoint is 130 and the frequency is 7. All right, so the only thing that we're missing is the coordinates for the midpoints, the coordinates for the beginning and the end of the polygon. At this point, I'm going to get rid of the bars, if I can catch the bars without getting rid of other stuff. There we go. Now, as for the two remaining dots, the one at the beginning, at the end, the frequencies are obviously 0 because those points did not go up at all. But the question is, what are their midpoints? Well, the one at the end is what we would get if we continued the midpoint pattern forward. And if you notice, these are all going up by 9, which happens to be the class width as well. So if we continue that +9 pattern, the next midpoint would be 139. So we can now label this last point as 139, 0. And the first point, if we did the midpoint backwards, instead of adding 9, subtracting 9, 94 minus 9 is 85, which means that first midpoint is at 85, 0. And that's how you can locate the midpoints. Now, I do want to make one more comment about how you label the axes when you are graphing a frequency polygon. If you'll notice, the horizontal axis is still labeled with the lower limits. But if a frequency polygon is existing on its own, meaning that I don't have the histogram under it, then those lower limits are actually quite irrelevant. What we could do instead is just put the numbers that are relevant. The numbers that are relevant down here are no longer the lower limits. The numbers that are relevant down there are, excuse me, the actual midpoints themselves. So 85, 94. It's not wrong to leave the lower limits down there, but if we're only counting midpoints, then why are we not just using those? I know what some of you are thinking, just show me what to do in the homework. You should know by now I'm not just about the answers. The next midpoint here is 130. And then the last one over here to end it is at 139. So it's not uncommon for a frequency polygon's picture to have its horizontal axis labeled specifically with the midpoints, as opposed to the lower limits when it was a histogram. All right, let's take a look at the homework and we'll be done. I still have the homework question up from the previous example where we drew the histogram from this frequency distribution that we had before. For the rest of it, notice on the horizontal axis, the midpoints are already labeled for us. How convenient. You just have to remember that the first and the last points are on the horizontal axis, so they don't go up any, but the other ones just go up the same frequencies as before. The first frequency was 4, so we can raise this up to 4, or not. Looks like it's just going to skip by 5s. So we don't have a choice. We got to type 4 there. The next frequency was 19 and then 38. Can I drag this one up? We'll just type it, 19, 38. And then the last two frequencies were 25 and 7. So unfortunately, from my perspective, or maybe fortunately from yours, the online homework makes this problem virtually trivial. You just have to remember that your polygon begins and ends on the horizontal axis, where the frequencies would be 0. And check mark, we got it right. That would be the end of this section.